Hi everyone, thank you for coming in this tool in action. I hope that you had some great time at Devox UK for these 2 first days. And today we'll be together to talk a bit about signals and in the React ecosystem, even though I will talk about things that can be applied to the other frameworks. We'll try to understand a bit how it works in React. So I'm Henry. I'm a software engineer at Datadog. Datadog is a SaaS company that allows you to monitor and secure your application at any scale, anywhere, anytime. But we won't talk about that today. First, we'll try to remember a bit how we handle states today in React. Then we'll see the difference between signals and the hooks. And we will have a bit of fun by creating a small demo. How we handle the states. First, does everyone is doing some React here? Raise your hand. Okay. Have you ever used some tools like Redux or Zustand to manage your state? Yeah, raise your hand. Okay. So you'll understand the mess that it is to handle states and how painful it is to set up all that things. For the other one, we'll just do a little recap. So React works as a tree. So this is a small app, so with a root component and some child component. And at a point, we'll want to put a state in it. When the state updates, it will update the component and all its children. Maybe your app grows, you need this state at the opposite side of the tree. And so basically you just need to put your state at the top. And every time that your state changes, everything will re-render. As you can see, it's not really optimal in terms of rendering and performance. To try to track a bit all this rendering, we have some tools like React Dev Tools that allows you to easily track your renders, profile, and debugs. But a small warning, on some really big app, the profiler just crashes, so it's kind of useless. To fix this issue, React provided the provider and the context. So the context, at the opposite of just a state, will propagate the state to the component that it needs to re-render without re-rendering all the child. But the same thing, at a point you will have a lot of providers that will render a lot of components, and you will just end up with the same issue. And for some of you, you will end up in the hell context provider. Basically, your root app will look like something like that. You don't know what is happening. You just put some stuff in it, and it works. But yeah, your main app, your main .tsx just looks nothing. And so the signals appears. To be simple, to try to explain what is a signal, it's just simple and efficient. So basically, it's a piece of state that can be read and updated. It has that value property, and it detects changes on the signal value that the component will automatically detect it when the value change. So the UI components read the signal value and become a subscriber to it. This subscription means that the component is now aware and dependent of the signal value. And if the signal value changes, the component will update. So let's take back our example just before. So we have the same component tree. And at a point, the same thing, we just want to put a state at the same place. The big difference is that when the signal value updates, it will update a piece of the component. It will only update the value that needs to be updated. So we don't re-render the whole parents, we don't re-render the child, and we can see directly that there is some big performance gains. For now, I'm talking about React, but all these concepts applies to all the major framework. In Angular, Preact, Vue, and Solid, this is already the norm to use signals. In fact, in React, we are using the Preact library from the Preact team, and we are importing it in React. So it's not native in React, but it's from the Preact team. So let's compare a bit the signals and the hooks. The hooks and the signals both reactively respond to a change in data or state. So they both aim to be used for state management, enable component application to reactively respond to change in data or state. The big difference is that hooks, it's for component rendering, whereas signal is at data level rendering. So we have a more granular rendering, and it's only the part of the UI that depends on the data that will be re-rendered with the signals. Hook, if we like them or not, is there since 2019. Whereas signal is like a really recent concept from a third-party library that patch React, in fact. The hooks are only available at components level, whereas the signals can be declared and used everywhere. How many times would you just wanted to use a hook, but it was a function or something like that? Here, you don't have this issue anymore with the signals. You can just import it directly in your file. And the hook, even though it should change at a point, the hooks, you need to declare the dependencies. If you forget a dependency, your hook will want to recompute it. It won't be recomputed. For the signals, all the dependencies are automatically tracked, and the signal will be updated when the dependencies change. So this is a small comparison between the virtual DOM from React and the one with the signals from Preact that has been optimized. This is coming from the Preact website, so I kind of bit selling that part, but it works. But how they managed to do it? First, all the signals are lazy by default. That means that only the signals that are currently used somewhere are observed and updated. All the other ones don't impact the performance. Secondly, we have some optimal updates. If a signal value hasn't changed, the component won't render. So only that if a dependency is updated, the signal will be recomputed, and then the component will be rendered. Of course, we have the optimal dependency tracking, as I mentioned just before. So since it detects automatically the dependency, it can decide if a dependency needs to be added in the array of dependency if we compare a bit with the hooks. And we won't forget something. We won't put some dependencies in extra that could affect the performance. And of course, you have the direct access of the value. You just directly access the value with the .value property, and that's it. And this is something that I want to mention, because every time that we are saying, yes, add a new packages, for example, the Redux package is super huge. Here, it's few kilobytes. So in your bundle, it won't impact too much the size of your bundle, at the opposite of Redux, for example. OK, so before deep diving in the demo, I just want you to show you a bit how the signal works. First, you declare your signals by importing the signal from the Preact library, and you just declare it like that. You just declare a new signal. If you want to reassign the value, you just reassign the value, the .value property with the new value. So count that value plus plus, just add +1 on the value. And if at a point you want to use it somewhere else, you can just import that signal in another component, and that's it. Of course, you have some tools, like our favorite use effect hook, called effect. But you have some also computed, for example, that allows you to compute some signals. So you have all the same mechanisms and the hooks. So how does it work? If we want to recreate like a class signal that will kind of mimic how a signal works, it will be like that. So first we have a constructor with a .value property and a list of subscribers. We have a get. When a subscriber wants to access the value, we'll register it in the subscribers and we'll just return the values. If we want to update the value, if the value is different, we assign the new value, and then we notify all the subscribers. Oh, sorry, it's in French. I didn't notice that. And then you have the notify that will just notify all the subscribers that they need to be updated. So it's kind of a pub/sub mechanism for those who do a bit of backend, where we'll publish a notification to update, and then all the subscribers will update directly. Okay, let's play a bit. So first, we'll create a simple to-do app. When I say simple, it's really simple. We'll use the hooks to manage the state, and we will try to make it evolve a bit. And then at the end, we'll migrate it to the signals, to use signals instead of hooks. It's in purpose that it's quite simple. It's really to really focus on the mechanism of the signals. Okay. So this is my to-do app. As I mentioned, it's quite simple. So there is an input to put whatever I want. There's an add button, and there is a navbar. I put some console log in the different components to see exactly when they render and when they re-render. In terms of code, I have my app.tsx with my navbar and my to-do list. My navbar is just 2 links. And my to-do list, for now, all the actions are commented. It's just an add button, as I mentioned, in input, and then I display the list of the to-dos. So to manage the states, first I will work to add the to-dos. So what I do is just using a use state. So I do just a set to-dos and then update the new list with just an ID. If I want, so I have to save to-do. Okay, I have my to-do. This is nothing complex. There is a checkbox to say if my to-do is checked or not, and I can remove them. So for the toggle, it's just an update of the state where I try to find the ID and I put it as completed. And for the remove, I just filter the to-do with the specific ID. So like that, I can check them and I can remove it. So if we focus a bit on the console to see the render. So we have the app, we have the navbar, and we have the to-do list. For now, it's logic. We are rendering the whole app. When I'm typing in the input, everything, all the to-do list render. This is also logic. And when I'm adding something in the to-do list, only the to-do list render. Nothing fancy. But now, there is a new request. I want to have the number of completed to-dos in my navbar. I know. I search for this one. So what I will do is just I will migrate my state in the app directly. So I will take my state here. We'll just export that, otherwise I will forget it. I will declare my to-do list. Up, I import everything. In my to-do list, I have just need to declare an interface for my to-do list props with my to-do list. Perfect. Sometimes I love Copilot. To-dos, set to-dos, and Ta-da. Okay, it will. Okay, don't. Why it doesn't want? Why it doesn't want? Oh, because here it's to do. No. Okay, it will be React that dispatch. Okay. Okay. So in my app, I will just pass my two props, so the to-dos and the set to-dos. Perfect. And now in my navbar, same thing. I will just declare. I just need the to-dos. That doesn't need anything else. But I will pass my to-dos to-dos. I will just import it. So it's happy. To-dos navbar props. Okay, and I will put it here like a completed. Perfect. Sometimes it's really smart. To-dos. I'm not focusing too much on the code. It's not the big part to pass some props. So now I don't have any completed. That's normal. That's logic. If I type some to-dos, my to-do list is rendering. And then if I add it, all my app is rendering. If I'm checking something here, all my app is rendering. So of course here it's a to-do app, it's a small app, but we can imagine that if something in your main application is rendering at the top component, everything will re-render. So you can already assume that there will be some big performance issue. Also, when I refresh, I lose all my data, so I will want to save it in the local storage. So this, I will just use a use effect, a use effect in order to do so local storage set to-dos up to-dos. And so here I will just instantiate it. So it's like this. It's smart. In fact, there is a code here just here, so it's not that smart. So like that, every time that I'm saving something, that I'm doing something, I have it in my local storage, if you can see it. And so we can track it. And when I refresh, everything is there. Okay. For example. But we see that there is some limitation for that. So now the goal is to migrate it to signals. So I will do that. I will have to speed up a bit. So same thing as before. Oops. I have, so as I explained just before, I will just use my signal in a different file that I import from Preact. I have a get to-dos that just does what I've done to instantiate my to-dos. And now, what I will do, it's basically all that I have done before. I will just remove it. And instead, my to-dos will come from my signals, but I need to access this with the dot value property. Why is not happy? Oh yeah. Here I have to do. It's a to-do. And the set value, as I said just before, what we do, we just reassign the dot value property, and it works. So in my case, I just reassign my dot value with the filtered version of the signal. For here, same thing. So here I will just do to-dos dot value equal there. And to-dos dot value. I'm just reassigning my to-dos, my to-do list. Here, same thing, to-dos dot value. Hop, to-dos dot value. perfect. And in my navbar, so now I'm not using any more of these props, but I import directly my to-do from my to-do list. Okay. Up, and here we can remove all of that. Okay. So technically, if we remove, I will just comment that, it should continue to work, hopefully. So we'll do signals is fun. Perfect, it works. The completed is still triggering. I can still remove them. Seems to work for now. There is just one feature that I didn't did for now. It's the effect part. So just to show you that I can declare it everywhere, I will just declare my effect outside of the component. And so I will do exactly the same thing as before. So I will write in the local storage my to-do list. And that's it. I migrated everything to the signals. Okay? But if you look closely, okay, it rendered the to-do list. But the navbar is re-rendering, but the completed didn't change. But I told you it's only if the value changed. So basically, here the number of completed didn't change for now. So it shouldn't re-render. That's because I didn't use the computed function. So the computed function allows you to compute a signal based on another signal. So it will derive the signal to another one. So I will speed up a bit. So completed to-dos, completed to-dos, it equal computed, and the computed is to-dos.value.filter value. Okay. And now I'm not using anymore the direct to-dos. And if I look closely, it's a signal, but a number because we are using the lens. And now, if I'm unchecking it, this is the magical part that I love. Wait, it's not working. It was working. Oh, yeah. That's it. The to-do list is rendering, the completed change, but the navbar didn't re-render. Don't know if you... The navbar didn't re-render, but the value changed. So you can see directly as fine the rendering is powerful and as fine you can do some re-rendering. Okay, perfect. So what have we done? We have seen how we can migrate hooks to signals. We have seen the different performance improvement. This is like not at all the UI. And we've seen a bit of helper function. But this seems a bit too much perfect, in fact. So we'll see why you should be careful a bit with the signals. First, it's kind of immature. I mean, it's not, it's immature, at least in React. Compared to other concepts like hooks, Redux, there is few libraries, few tools, few integration with signals. So be careful with that. The community is still small, is growing, but you can't just say, hey, I will switch everything on something that maybe in 2 weeks will die. I don't think in 2 weeks, but in a few years it will die. The learning curve. You will have to relearn everything. All the concepts that you have with the hooks that took years maybe to clearly understand how the rendering cycle works in React, just throw away everything and just relearn everything, almost. Of course, the React integration with all the ecosystem. We don't know, it can work with some hooks, but we don't know how it will work directly with all the libraries that will continue to work with some hooks. Also, don't forget that we are importing some Preact stuff. the Preact signals is based on the Preact core. So we are using some Preact things in React, which is not always the best solution. Of course, we have some performance improvement. We have noticed them right here, but it's some specific use case. So sometimes hooks, we need the hooks, and we need the fine-grained dependencies for the hooks that we want. So be careful with that. It's good in certain situations, but not at all. Debugging and dev tools. We have our nice dev tools for React. For Redux, we have the same thing, the Redux dev tool. We have a lot of dev tools, but this won't work with the signals. So if you have some debugging issues, good luck with that. Since the community, and it's still quite early, there is a big adoption risk. If the React team and the React ecosystem don't adopt it, you won't be able to continue to use it in a few years. Today, the React team is quite focused on the server-side rendering, so it's not the main priority to change how we manage our states. Implicit reactivity, so since the dependencies are decided by the signals, it can be an advantage, but it's also an advantage, and so we could have some unexpected behaviors, and we lack of some manual control on how we want to handle the rendering. And for some big complex system, we just don't know how it will work. The complexity of our system grows a lot with years, and so now we don't know, we are not just building some small website with a small to-do app, so we don't know how everything will interact in this ecosystem. So to conclude a bit, yes, signals are great, but yes, also be careful with the signals. Like every new technology, try it, play with it, try to understand the mechanism behind, but just wait a bit. Took a step down and just wait a bit that the tool is a bit more mature and that we have some a proper community around it in order to start using it in production at your own risk. Thank you very much. I hope that you enjoyed the talk. And we have 2 minutes for questions if you have some. Yeah.
I was just going to ask about, naturally, if you have state at the top and you're comparing it to signals, the signals will have far fewer re-renders because it's not re-rendering the whole tree.
Yeah.
When you're using context, I actually can't remember, presumably it doesn't re-render the whole tree. It re-renders whatever uses the context.
Oops. What have you done?
I don't know if that's true.
Yeah. I'm just trying to refine my slide. Where is it? Context.
Yep.
So yeah, the context will skip the components that doesn't need to be rendered.
Okay.
So
That would be like kind of equivalent to how signals
yeah. For example, at Datadog now we only rely on context. We don't use you don't use Redux or whatever. We mainly use the context in order to manage our states, because we will skip most of the components to render, and then afterwards we render them. So it's kind of a good mix, but at the end you just end up with a lot of context, and it's hard to manage. Also, do we have another question? No? Yeah.
Should you kind of avoid the values of the signals in hooks dependency arrays?
So the question is, tell me if I understood correctly, if I can use the signals in the dependency arrays of the hooks.
Should you avoid it?
Okay, should I avoid it?
Trigger the re-rendering of components.
Should I avoid using the signals in the dependency, for example, of hooks and stuff like that? In my point of view, it's yes, because it's two paradigms, totally different, two different paradigms. So you shouldn't mix up things. So it's like, for now, I love a new library called Nux that you do the state management in the URL. So the idea is not to mix up the different stuff. For example, Redux, you will try to you won't put Redux things in uState and things like. I mean, you won't mix up all the state management together. So the answer is yes. This is more practice issue, I think. But yeah, try to avoid mixing up stuff because it will be impossible at the end just to follow up what's happening. It's better just to stick to signals when you want to use signals, and to stick to hooks when you want to use hooks. That other question? We don't have any time, but I'm available for the rest of the day. So if you have any other question, don't hesitate. Thank you very much.